Hello, today we are going to be looking at designing a Morse code translation engine being run on an embedded device. For the agenda, we are first going to be looking at a problem with the problem overview, the requirements, design, and then finally we're going to finish up with some code and a demonstration. The problem overview is to create a text to Morse code translation engine in an embedded device. The user story we are going to be using is, as a user, I should be able to input text into a serial monitor and see the LED flash for the converted Morse code equivalent of said text. To go over some requirements, the first one is to develop the language in a language executable on Arduino. Second one is to execute on an Arduino. For us, that will be our demonstration. Third, ingest user-typed strings. Fourth, translate user-type strings to Morse code. 5, display translated Morse code via LED or LCD to the user. We are going to be taking the LED approach with flashing on the ESP8266. 6 is the design utilizing a round-robin or loop approach. 7, user can exit the loop via a specified key or word is entered. And 8 is to develop using either Arduino Sketch, AVR Dude, AVR Studio, or WinAVR. We chose the first one and are utilizing Arduino Sketch. So for the design of this overall, we have kind of two main parts. The first one is the setup, which really sets the LED pin, serial monitor, and prints some useful help information, for instance, how to stop the machine. Then we go into the looped phase. So for the looped phase, we wait for a user inputted string over, for our instance, we used serial monitor in Arduino IDE. When a user inputs a string and sends that string over the serial, we then look at that string and check that if it's equal to the exit code. If it is equal to the exit code, we then exit and restart the board. If it's not, we take that string, we convert it to uppercase, and we start looping over the characters in said string. For each character in the string, we look up the character in the alphabet string, which is a pre-initialized kind of global variable that we will be using. We get the index of the character in that alphabet string. We take that alphabet index and find the Morse code equivalent for that index. This is stored in a Morse code array. It is important to remember that the alphabet string is of equal length, and each element or character in the alphabet string correlates to the Morse code array and the Morse code equivalent of said character in the alphabet array. So, for instance, if we look up the character A, and that happens to be index 1, the Morse code equivalent will also be index 1 for character A. So now that we have our Morse code string, we loop over the characters in that Morse code string, and we look to see that it is either a dot or dash. For either one, we set the LED pin to low. Because we're using the ESP8266, the LEDs are inverted, so low will actually turn on the LED and high will turn it off. We delay for the appropriate length on pre-specified variables for dot and dash, and then we set the LED pin to high to turn off that LED. And we continue to repeat that loop till we are done with the Morse code string for that character, and then we repeat it again for all the characters in said string. And then at the end, we actually print out the conversion. So now we will go into our code and design overview. Now that we have our code pulled up and a comms serial monitor to the right, let's start going through. At the top, we initialize some simple constants that are used throughout the process, such as our LED built-in pin, the array of strings for the Morse codes, the comparison string, including the entire alphabet and some other keywords. Then we have duration for dot and dash, and then we have some functions which we will get into later. With the setup, we first begin by monitoring the serial, we set the LED path, and then we print out some help statements. Lastly, we are turning the LED pin to high. It's important to remember that the LED is inverted, so a high actually sets it to off for this ESP8266 board. Next we have our loop. This loop just starts by waiting for an incoming string, as we can see here. It then compares that string against the exit code. In our case, if you type in all capital stop, it'll go ahead and stop and exit or restart. Then we print out what text or incoming string we are converting, and then we pass that to the functions. Going up to the functions, we can see that we start by converting it in place to uppercase, and then we create an empty converted input string, which we will use later on to store the converted Morse code version of the input string. So we start this handling the input string by looping through the characters. For each character, we get the input of comparison, and then we use that index to look in the Morse code string array, and then from there we get the Morse code string equivalent. We then take that Morse code string equivalent and we start processing that in much the similar way, where we go down to this process Morse char function and we loop through it, presenting the LED for dot or dash respectively, and then we delay as a dot between each one. From there, we pass it back, we delay as a dash again between each character, and then we return the converted input if that's the last character of the input text. So let's look at what this actually looks like. I am clicking the reset on the ESP to restart it, and we kind of see we have some initial output, and then we have a welcome to text or Morse code converter to exit input stop. Let's go ahead and run test. We can see we have that initial output of text to Morse code. Now the actual ESP8266, as we can see, is converting it to Morse code and flashing the LED. And at the end, we get that converted text out. Lastly, if we look here and we want to stop the program, we can just input all capital stop, send that over, and we can see user exception, we are exiting the program.